Let me tell you why you're here. You're here because you know something. What you know you can't explain, but you feel it. Trying to free your mind.
This article is from Government Technology or govtech.com. It says microchip breakthrough could reshape future of AI. A prototype microchip design that was revealed today by IBM could pave the way for a world of much smarter devices that don't rely on the cloud or even the internet for their intelligence. And it says a prototype microchip designed today, revealed today by IBM, could pave the way for a world of much smarter devices that don't rely on the cloud or internet. Could help soldiers operate drones, ground robots, or augmented reality gear against adversaries who target electronic emissions. But the new chip, modeled loosely on the brain, also paves the way for a different sort of AI, one that doesn't rely on big cloud and data companies like Amazon or Google. So it says, unlike traditional chips that separate memory from processing units, the North Pole chip combines the two, like synapses in the brain that hold and process information based on their connection to other neurons. It says IBM researchers call it a neural inference architecture that blurs this boundary by eliminating off-chip memory, intertwining it to compete with memory on chip, and appearing externally as active memory. It said this is important because today's computers have at least two characteristics that limit AI. And they said AI needs a lot of power, and two, there's a limit on how many transistors you can actually fit on a chip. But IBM thinks that the North Pole chip can help with that. It says what we really set out to do is optimize every joule of energy, every capital cost of transistor, and every opportunity for a single clock cycle. So it has been optimized along three dimensions: energy, space, and time. So it says the North Pole chip has 2 billion transistors and 256 cores. And it says there are chips with more of those, but it says North Pole's chip allows it to operate exponentially with more efficiently on tasks like processing moving images. It says if you wanted to connect a lot of an enterprise cloud environment to run ChatGPT, you could shrink that cloud down considerably. And cloud computing usually takes massive servers, but the idea of this chip is that you would need fewer chips to run things like drones and robots. Now, the interesting part about this to me is the Pentagon has been invested, and the Department of Defense has invested money into this chip. So it says IBM has been working on such neuromorphic chips for more than 10 years, funding from DARPA's Synapse program. And it says the program spent more than 50 million between 2008 and 2014, and the Department of Defense has since 2019 invested another 90 million on top of the chips, according to the Pentagon. And then Assistant Defense Secretary said that this is a prime example of what we would call patient capital. Now, of course, in the Department of Defense, they're also looking for ways to make war more efficient. So he said, for us in the Department of Defense, we've always been looking for low size, weight, and power, and then increased speed for our processors. With the advent of generative AI, we recognize that to do in computation in low power fashion, we would need this kind of architecture, especially in a contested environment where our signals may be jammed. GPS may be denied to be able to compute at a tactical edge is an advantage. It said smarter and independent chips vastly improve the ability of various military systems. So drones, ground robots, soldier headsets. Department of Defense is invested in this, so it will be used for war. It will be tested in war. And it says various military labs, Air Force Research Lab, and the Sandia National Lab are already looking for uses of the prototype. And it said that the North Pole would even help the military do more with fewer and more domestically producible chips. And says, due to the Chinese invasion of Taiwan, that could be a concern in the future. So right now, this chip is at 14 nanometers, forming at 14 nanometers, which is similar to the things we have in our iPhones and other commercial electronics we use. And it's all being produced in Asia. So they can, the fact that they're able to do some of these computing at lower resistance and other chips is pretty interesting. But if they can figure out a way to shrink it down even more, and if the United States actually can develop these chips without waiting for Taiwan to do it, that would be, they could probably learn to fabricate these chips in large quantities. That would that'd be very interesting for our military to see what type of weapons they could, what type of drones or technologies they could come up with and deploy with little to no resources. But that's all I had in this video. Let me know what you think about this. Looks like the feds are all over this new IBM chip. I'm sure this isn't the first time IBM has been involved with government projects, and it won't be the last. But let me know what you think about this. Is how soon could this be used commercially in just everyday life, or is this just going to be military only? Will it ever get in the hands of the average consumer? For watching this on Robo Odyssey or YouTube, I greatly appreciate it. Thank you. Leave a like or dislike if you feel inclined. And thanks. Take care.